Good morning, everybody. How are you? It's the last day of the conference with sessions, and tomorrow there is a workshop day. So I'm starting the first session in the last day, and what a great hall! So big. I want to start with a scenario. In a web page, you want to create a drop-down list. Okay, drop-down list needs some data, and you have options to get that data from the server and do stuff. So one option is to render all the data for the drop-down list on the server. You know, traditional web applications, I do create the web page with the drop-down built in with all the options, etc., etc. The other option is, of course, to get the data with Ajax to the client side and do with it, create with it the drop-down list. But what if I could bring that data and use storages on the client side? You know, once you bring that data to the client side and you have more than one drop-down list and you have a lot of Ajax requests, or, for example, a lot of rendering on the server side, you just pay with CPU on the server, or you pay with latency or web resources that you go to the server, bring data, and etc. And this is what I'm going to talk about in this session. I'm going to hopefully show you things that you never saw, or you saw but you don't use right now. I'm going to show you how to use storages in web pages on the client side, browser storages. This is the main topic of this session. So I'm Gil Fink. I'm a senior consultant and architect working for a group called Sela Group. I'm an MVP of Microsoft MVP in ASP.NET area for the last 5 years. I wrote a book, Pro Single-Page Application Development. You can buy it in Amazon or through Apress, the publisher. I also wrote, I think, 4 MOOCs, Microsoft official courses, that you can take in any Microsoft official learning center. So I have the HTML5 programming course, and all the Windows 8 with HTML5 and JavaScript courses from Microsoft. I am the co-author of those courses. What we are going to do here is first recap. Who attended my yesterday's session? Okay, so if you attended my yesterday's session, you probably know what I'm going to talk about in the recap, but I will do it very fast in order to get to the main thing. The main thing, we are going to build an app. That app is going to show you the transition from one situation, which is I don't store anything on the client side, to storage on the client side, and we are going to take that application to offline, meaning that we are going to create an offline web application that uses storages on the client side when you're connected, and when you're disconnected also, okay? At the end of the session, I'm going to give you a lot of time to question and answers, and I will summarize the session in order to make you understand that storages in the client side are here, and you can use them today, and you could use them in the last 2, 3, or 4 years. Okay, you are not using them probably, or you are using them, but you don't know that you're using them because libraries wrap those storages for you. But in the end, you can create better user experience by using those storages. You don't have to go all the time to the server. You don't have to render data in the server. You can create your data on the client and save it on the client side. So a recap. What is HTML5, which is related to those storages that I'm going to show you? HTML5 is just a word, a buzzword that says I have an HTML, CSS, and JavaScript for building modern web applications. If in 1997 there was the recommendation called HTML4, then HTML5 just add to that recommendation a lot of good stuff. For example, yesterday I showed the attendees of the session that you can track users using your browser using an API called Gil Location. So HTML5 is here. It is kicking and bouncing for the last, I think, 7 years. Okay, from 2006, when it the first working draft were created, until now. But only in 2009, it gained a lot of attention. You know why? The people that attended yesterday's session needs to say yes. Okay, Steve Jobs told everybody and to the press that Flash won't be a part of iOS ever. Okay, so how can I create an interactive website or web application using only HTML, CSS, and JavaScript? That question just drove HTML5 to what it is today. And most of the modern browsers give you a lot of the power that HTML5 brings. Not IE, okay, but most of the other browsers. Sorry, Microsoft. And you can use a lot of the things that I'm going to show you today with all of the browsers, except IE8 and lower, of course. So if you are targeting IE6, 7, and 8, please don't do that. Okay? So what's in the umbrella of HTML5? First, we have a lot of new semantic. We have a lot of new elements, structural elements, inline elements that you can use today in most of the modern browsers. More than that, today's session we are going to talk about offline and storage. We're going to talk about 3 APIs in HTML5 that gives you the opportunity to store data on the client side using client-side storages and to take your application to the offline. Make it an offline web application. No more 404 pages when there is no connectivity in the user's computer. Device access. I said the geolocation. I can use GPS and the vibration of mobile phone or even the accelerometer using JavaScript. Yes, plain JavaScript. I can access a webcam, I can access a microphone using get user media function, and etc. A lot of devices are enabled using just JavaScript. More than that, connectivity. Who tried to do a cross-domain request using JavaScript? Raise your hand, please. You know what happened when you try to do that. The browser will stop you or block you because you can't do that using JavaScript. So you need to do JSON-P or other things to try to do it on your own. No more. Cross-origin resource sharing is a new API that enables you to do cross-domain requests using JavaScript. More than that, yesterday I showed WebSockets, a new bidirectional socket communication using JavaScript on the client side and WebSocket server. You can create semi-real-time web applications using WebSocket API. It will never be real-time because it's not C++ or C or other language, and you have the network to pass. Okay, but it's semi-real-time. Multimedia. HTML5 brought us the video and audio tags that enables you to hear audio using a new element called audio and see and hear video using the video tag. 3D and graphics. The 3D and graphics, you have 2 main models that you can use to create graphics in the browser. You have the canvas element that helps you to create using JavaScript pixel graphics, 2D pixel graphics, or you can use WebGL API to do 3D graphics in the browser. And you have SVG, Scalable Vector Graphics, which is another model that enables you to create elements of, for example, ellipses, rectangles, triangles, etc., in the browser as DOM elements. So you have a vector graphics ability inside of the browser. Performance. Yesterday I showed web workers. Web workers enables you to do concurrency in the browser. You get a thread for a worker from the browser, and you can do concurrent things. For example, algorithms and calculations and things that are very, very heavy inside of the browser. And last but not least, CSS3. CSS3 brings a lot of power to style and to lay out your web pages. And more than that, it can create animation using the animation CSS3 module. You can create transformations, transitions, and more. No more doing that using JavaScript. Use CSS for simple things, and the gain is, of course, less CPU, of course. But with that, this is the overview of HTML5. Let's talk about storages. And in order to talk about storages, I want to start the demo that I will show you all around this session. So let's open Visual Studio. Most of the demo is JavaScript. If you like C# or other object-oriented languages, sorry. We will see C# a little bit, but most of the demo is JavaScript code. So let's try to understand the scenario of the web application that I've written. My wife always sends me to a grocery store with a list. Sorry, with a list. Okay? And she said to me, Gil, go buy all the stuff the kids need to eat. Please buy all the things that I wrote. But you know, you take the paper that she gave you and go to the grocery store, and once you are there, you just lose that paper, and now you're in a big, big trouble. So I created a simple grocery store list application that I'm going to show you. So let's run the application first to see what we are going to have and what we are going to create. So this is my grocery store list, and as you can see, I have a text box that I can write all the items that I want to buy, and I can add them, and you can see that it's a very, very simple application. I have a drop-down here that have the items that I can pick. Of course, I can pick more than that. Pressing the plus right now won't work because I didn't create anything in the client side currently. This is just pure HTML. Let's see the HTML itself. So I'm going to open the HTML here. And what you can see here is that I have a text box and a button for the grocery, for adding grocery items. I have an unordered list for grocery items to show up. And I have a backlog that I'll use later on to log things. More than that, yesterday I talked about the data list element. The data list element is an element that you can create to store some things that would be auto-completed by the browser once you put them, you point the text box to this list using the list attribute. Okay? This is a new HTML5 element. So we want to start building our application, and the first thing that I want you to notice is that I arranged the application in the script folder. I'm using jQuery for building the application. I've put it in lib or vendor folder. You can use it with the vendor folder name. And all the application is stored here. But the application currently is not implemented. So let's start creating our scenario. The first thing that I want to create is our data structures. So let's create our data structures. First of all, I want you to take a look at what is written right here. The first thing that you might notice is that I'm using a IFE, immediate function execution expression. IFE is used to create a function scope and to run that scope once to initialize things. For example, what you see here in my code is that I'm creating a namespace using that IFE. Here is the start of the IFE, here is the end of it. Once I've created the function, I'm running it right here. And what I'm doing here is I'm just initializing an NS for namespace with NS if it is already exists, or a new object, a new literal JavaScript object. What I'm doing here is creating a namespace. A namespace in JavaScript helps you to gather around things in a namespace, like you do that in C# or in other languages. Okay? So once I've created that namespace, I want to expose from that namespace a grocery item object. This function is a constructor function. You can see that it's a constructor function because I'm using uppercase for the name of the variable. This is the only thing that differentiates it from other functions, okay? The uppercase. I could have used it as a real function, but it won't have a meaning without the new operator. So I've created a grocery item constructor function, which helps me to create new grocery items. Every item will have a property called ID, which is the ID on the server side. We will have a storage on the server side, and a key, which is the ID in the client side. What is the product to buy, and the status. The status here is insert right now, which I need to insert the item in the server side. Later on, we will see and we'll understand why I use that status at first place. What you see here is that I've created an enum called item status. It includes none, insert, and delete, which will mark my current object with a status that I need to do. Whether it's none, don't do with the grocery item anything. Insert, you need to insert it in the server side, and delete, you need to delete it in the server. Okay, so we have our data structures. Let's save it, and let's implement the application itself. So here is the application right now. The first step in the application. I have a product index in order to understand what is the current index that I'm going to use, what is the key that I'm going to use for every product. And I have an in-memory storage. It's just a JavaScript array that I'm going to use in the client side to store the data I have. Down at the bottom, I'm wiring an event listener to the DOM content loaded event. The DOM content loaded was presented in HTML5. That event is used to express that the DOM, the document object model, was loaded. All the content of it was loaded by the browser, and from that you can start using the DOM. That event will happen before the load event, and if you are using jQuery ready function, it is going to use the DOM content loaded if it is supported in the browser. If it's not supported, they will wire the event of ready to the load event. You can see that I'm starting the application using the content loaded function. Let's go up and see what the content loaded is doing. So the first thing that the content loaded is doing is wiring the click event to the button to add new grocery item lists, grocery item. If somebody clicks that button, I'm taking the value from the text box, I'm creating a new grocery item using the constructor function that you saw earlier, the data structure that I've created. I put the product name inside of it, and I'm passing the product index, which is currently 0 when the page is loaded, and I'm using the +1 to increase the product index by 1. Once I've created the new item, I'm using the add list item function, which is what this function is going to do is just add the item to the DOM. That means that I'm taking the key, creating a new in-memory div, a text div, with the product name that I want to buy. I'm creating a delete button for each of the items in order to enable you to delete the grocery item once you've picked it in the grocery store. That button will use the delete item from list function. We'll see it in a second. And I'm wiring the item that I've created to an unordered list using this very long expression. Okay? I'm just setting the DOM, and I'm putting inside the DOM all the item that I've created. Let's take a look at the delete item from list. It is just searching the item in the in-memory store, and once I find it, I'm removing it from the document object model. The last function here is show grocery list, which is iterating all the in-memory storage and just adding the list items. So if I have an in-memory storage list with items, then once the application starts, I'm just iterating it, and you see the items added. So let's run the application right now, and let's see what we got right here. Okay, so we have the same application here, and let's add an item, corn, and milk, and you want to erase the item. It is working, but you have a very big flaw in this application. What is the flaw? Pressing F5 and all the data that you have disappear. Because it's an in-memory array of items, then once you refresh the application, poof, all the data is lost. So let's talk about how to improve the application, and let's talk about web storage. Web storage is the old storage option in HTML5. What it gives you is a very simple dictionary, key-value dictionary, string-based key-value dictionary, meaning that everything that you save in web storage is string-based. It has very simple API, only 5 functions and 1 property, which is the length of the storage. And once you know those 5 functions, then you can use it as you wish. More than that, web storage is supported from IE8, so you can use it from IE8. I'm especially talking about IE because, sorry, IE is the, I would say, the last adapter for HTML5 APIs. It is exposing to you 2 objects that you can use. One is session storage, and the other one is local storage. The difference between both of those storages is their lifetime. The session storage lives as long as the window or tab is open. The local storage lives and persists its data even if you close the browser. That means that it is doing a serialization to the disk, and it saves the data that you inserted in the local storage. One thing that you must understand is that local storage and session storage aren't limited by their storage availability. That means that the browser gives you, I think, for between 5 megabytes to 10 megabytes, it depends on the browser, for each of the types. Okay? And you need to understand that web storage is per domain. That means that one domain can't take data from a storage or local storage from another domain. You can trick the browsers and create subdomains, and from that create many instances of local storage or session storage, and then blow up the hard disk of a user. Yes, there is a guy that did that. Just fill up his hard disk using subdomains. Okay, so one tip for you in working with local storage: clean that storage. It is persistent. It is between 5 to 10 megabytes of data that are persisted for your web application. So let's see how we can use the knowledge of web storage in our application. Sorry. Okay, so the first thing that I'm going to implement is the web storage. Let's close the application. And let's create our web storage. Again, you can see that I'm using a namespace, the NS, and an IFI to create a function scope and to initialize all the objects that I'm creating. First, I'm creating a storage object. It's an empty constructor function. I'm going to use it to wrap my storage and to not expose the local storage to my application. Inside of the storage object that I've created, I'm creating the following things. The save item function, which you can see is using the set item of the local storage. Okay, so once you want to save an item, you just set the item using the set item function in the local storage, which is part of the window object in the browser. And once you set the object, the item, you need to give it the key, which is going to be the item key for the grocery store item. And as I said, everything that is created in local storage or saved in local storage is string-based. So I use the JSON stringify function to stringify my object, my JavaScript object, and to serialize it inside of the local storage. Remove item function of the storage object is going to call the remove item function in the local storage. That function gets a key and just remove the key value pair from that storage. The next function that I've created is get all items. Get all items just iterate the storage, add the data in the storage to an in-memory array, and return that in-memory array. So if you want to iterate the storage, you just need to get the key for each index using the key function. The key function will return the key for the given index. And once you have the key, you can use the getItem function, which will return the item. The problem here is that the returned item is string-based. So I need to parse it into a JavaScript object. So I use the json.parse function to parse it to a JavaScript object. Once I have that object, I just push it into the items array that I've created here, and I return that item array. The last function here is getByKey. The idea of getByKey is just to return the item by its key. You just get a key, use the getItem function of the local storage, and you parse that item and return it. Okay, so we have a storage object, and the other object that I want to implement is a data service. I don't want to create the interaction with the server without a data service or a service that I'm going to use. So what is the data service? The data service uses our storage object, which is created here, and it exposes a few functions that I can use later on. The first function is save item local. The save item local we call our storage and save it and call the save item function that I showed you previously. The logger here is just an object that I've created here that log things to a backlog div that you will see later on once once I add the item to the grocery store item. Save item remote will go to the server to the endpoint called home save and give it the item that I want to save in the database on the server side. Yes, we have a server-side implementation. I'll show you it later on. Once the item is saved, the success callback is going to be called with a new with the data, which is the item that I saved. I will take that item that I got and I'll change its status from insert to none because it was inserted in the server side, and I will save the item in the storage in the client side. We have two more functions, delete item local and delete item remote, that of course delete the item from the storage in the client side or delete the item in the database on the server side using the home delete endpoint. The last function here in the last two functions here in the data storage are get all items and get by key, which delegates the request to the storage in the client side. Now that we have our data service, which wraps the functionality to communicate with the server database or with the storage in the client side, we can go to the grocery store and finish our implementation. So let's see our finished implementation. Okay, so the content loaded here was changed a little bit. First of all, I'm creating a data service object, and once I'm creating the item that somebody pressed, somebody inserted, then I add that data both to the client, save item local, and to the server, save item remote. The show grocery list will use the data service get all elements, iterate the list that I get, and create all the items in the DOM. Okay, I'm just adding the items to the DOM. Add list item here does the same thing like it did earlier. The only difference here is that once I want to delete an item from the list, what I'm doing is I'm getting the item by key and I'm removing it locally and remotely using the data service that I created earlier. And now let's run our application and let's see the end of this situation. Here you will see the log that I've created, logging the things that I'm inserting. Okay, I just inserted corn. Corn was saved locally. Corn was saved to the server. I want to add milk. Let's add milk. Milk was saved locally and to the server. I erased those, and corn was deleted locally. Corn was deleted from the server. And let's open the developer tools. One interesting thing in the developer tools in Chrome is that you can see the local storage and session storage. So if I open the local storage here, you can see the item to buy milk with its key, its status, which is none, and the ID from the server. I had items in the server side in the database, so it got a 13 ID. Okay, so we have an application that saves data in the client side, saves data on the server side, And let's go on and let's talk about another scenario. Okay, so I got into my grocery store and poof, I have no connectivity. Okay, what next? Getting 404 for my web application that I've created? Damn, I worked so hard. I created a fancy grocery store list, and now I'm getting a 404 page because I don't have connection to the internet. So let's talk about how we can improve the application, and let's talk about app cache or application cache. As it seems, HTML5 brings the opportunity to create offline web application using the app cache API. The app cache API exposes you the opportunity to download all the resources for your application to the client side, and once they are downloaded to the client side, they are always taken from the cache. The only way to refresh that cache is to change a manifest file which exists on the server side. So if the manifest file, which is part of the specification, changes, then the cache will refresh on the client side. Saying that, of course, you understand that you have a manifest file on the server side. Okay? So in order to create offline web application, you just need to point your HTML web page to that manifest file. That manifest file has to have very strict things that I will show you once we will see the demo. And you have app cache API. The app cache API enables you to detect when you are online and when you are offline using the online and offline events. You have a new property called Navigator Online, which enables you to understand whether you are online or offline. And using the API of app cache, you can swap the cache, or you can refresh the cache, or you can wire into cache events, meaning that the cache is currently refreshing, you can wire to events like that, and etc. So let's implement application cache into our storage application. So first of all, let's stop the application from running, and let's create our app cache. Sorry. Okay, so I have a new object that I'm creating called app cache utils. The app cache utils will get a status div ID, which is a div that I have here. Here's the div. And it will get an online callback, meaning that once I'm online, I'll do something. Once I'm offline, I'm doing something else. It will save that the status element ID. It will save a reference to that status element, and it will set up the application cache events using the online callback that I got. Let's take a look at that function. So the first thing that you need to understand is that application cache isn't supported by a lot of browsers, including i6, 7, 8, 9, of course. But from 10 and 11, it is supported. So this if will check whether application cache is supported. If it's supported, then I will wire the events to do something. If it's not supported, then no offline for us today. So once I know that the application cache is supported, then what I'm doing is I'm just wiring the onUpdateReady event, the function that will swap the cache and reload the page. So let's talk a little bit about what I'm doing here. As I said, in order to refresh the cache, the first thing that you need to know is that you have a manifest file, and using that manifest file, you need to change something in that manifest, and then the cache will refresh. The problem with that is that the cache will refresh only after the web page was loaded, meaning that the user will get the old version up until the cache is refreshed. Once the cache is refreshed, then the user needs to press F5 in order to refresh the old state into the new state, or you can use what I've created here, the swap cache and reload function. That's not a good implementation, but this is the specification of application cache. I'm also wiring the online and offline events, which will toggle the online div to online status, which means that you will see a green status, meaning I'm online, and a red status, meaning that I'm offline. This is the toggle function. Just remove a class from the div and put an online or offline class. The last thing here is the isOnline property that I'm exposing, function, sorry, which just return navigator.online in order to understand whether we are online or whether we are offline. Once we have the application cache, let's implement the grocery store with the application cache. So things change a little bit. The first thing here that you probably will notice is that I'm instantiating the new application cache util object. And once I want to save things remotely, I always check whether we are online or offline. That's important. So you have an if here that check whether we are in online state. Another thing to notice here is once I want to save remote, then I'll always check whether the item has a status of insert or delete. Because if I can't go to the server and insert or delete an item, then the save remote won't work. Okay, I need to know when to save the item remotely and when to delete the item remotely. Meaning that I have a problem here that I need to always know whether I'm online or whether I'm not. Another thing to notice here is here. Once I want to delete items, I'll just check whether the items whether I'm online. If I'm online, then I'll delete everything. If I'm not online, then I'll change the status of the item to delete and save the item local. Meaning that I'm always persisting the data in the client side, whether or not I'm connected to the internet. And once I'm connected to the internet, then I save the items remote. Here's the function that does all the stuff, save remote. Meaning iterate the local storage, check whether you have statuses of insert or delete, and go to the server and save and delete everything. Okay, we haven't finished yet. I said that you will see a little bit of C#, yes? You want to see C#? No, okay. We have to. So let's see the home controller here. The main thing that you need to understand is the manifest, okay? I'm exposing a manifest file. So I said that you have a little bit of restriction about the manifest file that you expose. The first thing is its content type. It must be text cache dash manifest. The second thing is content encoding, which must be UTF-8. If you're doing anything else, it won't work. The third thing is a little bit of problem using application cache. Application cache and HTTP cache don't work good together. Okay? So once you pick the application cache road, you need to disable your HTTP cache, and this is what I'm doing here. I'm just set my cache into no cache. Okay? Remember that because there are very, very bad bugs that you can create once you have both application cache and HTTP cache working together. Let's take a look at the manifest file. So the manifest file that I'm sending includes the following. First of all, you have to put the header called cache manifest or else it won't work. The second line is just a comment. I'm using it for versions, meaning that if I'm changing the manifest, I will change the version number, and then it will refresh the client side. Here you have a section, the whitelist section, meaning that everything here is going to be cached. Okay, I'm caching the site CSS, shop list GIF, all the GIFs, JavaScript, etc. I have a fallback section that will that you will things that would be called once something wrong happens in the cache, or the other thing that might happen is, of course, something won't work in the client side, so you have to have a fallback. Okay, so if something goes wrong, put fallbacks here. I didn't put a fallback here, and that's not a good idea. And every other thing that I'm not including in the cache is going to be put in the network. For example, if you have a login form, you have to have a network. Okay, so here I'm just putting star, meaning that don't cache anything else than those cached items. Okay, so we have our cache manifest, but as I said, we need to wire the manifest in the HTML. Where can you do that? So here we go. In the HTML, put manifest equals the endpoint of the manifest file. In my application, it's home/manifest. And that's all. Now I can run the application, and I'm currently online. Cool. Let's put ice cream. You can see that it persisted my milk from the previous example. Ice cream was saved locally, was saved to the server. I can erase that. If I'll press F12 in the developer tools, you can see the application cache here, and here's all the things that were cached. Okay? Now, I'm going to open another browser because I want to simulate application cache. Okay, you see here online, one thing that is cool in Firefox is the ability to toggle between work offline and work online. So if you want to check your application cache, Chrome doesn't give you that opportunity, but Firefox do give you that opportunity. You can see that we are currently offline. That means that if I'll save corn will save locally, and let's save it again, and let's erase a kern, and let's go online. And pay attention to the backlog right now. I got online, okay? The item was deleted locally, corn was saved in the server, everything is working. So we have a full functioning application using local storage and application cache APIs. But you might notice that I used local cache and it's a dictionary, and you might want to use a real cool database on the client side. Yes, you don't want to have a dictionary in your client side. That's awful. Let's talk about IndexedDB. IndexedDB is a NoSQL database, index-based, in the client side, inside your browser. It is supported from IE10. Again, Firefox and Chrome support that from ages, and just in IE10 it was added to the IE browser. And if you have very big data-driven application and you want to store things in the client side and you have a big database in the client side, IndexedDB might be your solution. Like local storage, you get between 5 to 10 megabytes of storage opportunity in IndexedDB. The only difference between local storage and IndexedDB is how to use it. IndexedDB works asynchronously, meaning that you have to request things from the IndexedDB, for example, to open, and it works with transactions. You need to create a transaction against an object store. Object store is like a table inside of IndexedDB. And using that transaction, you can search things in the database. You can put items in the database, and etc. One thing interesting about IndexedDB is that IndexedDB is saving the data as it is, meaning that you get hierarchy objects you can save there, and you can save there array, JavaScript arrays, and etc. You just need to know how to use it. So let's build our application using IndexedDB. Again, one thing that I forgot is there is no cross-domain in IndexedDB. It's per domain, like local storage. So what I'm going to do right now is go to the index here and just set some URLs, and we'll see the example, and I'll show you the code itself. Okay, so I changed all the URLs, and let's see how it works. First of all, how it works, and then we'll see things that are implemented. First of all, let's go to, okay, that's not a good thing because I didn't clear the cache, and the application I got it from the cache. You use app cache. So let's clear the cache. Let's run the application again. Let's open it. You can see here that now I have a grocery store object store inside of a DB called grocery store DB. Okay. Once I'm putting items inside of the IndexedDB, then they will show up as objects inside of the IndexedDB. You can see here object and object. Chrome gives you very good insight about what's happening in your database, and everything works. Let's see the code, which is probably the most interesting thing about IndexedDB. So the first thing here is the IndexedDB object, which is very, very big, so try to pay attention to what I'm saying. So the first thing that you need to know is that IndexedDB wasn't supported by all the browsers. So browser vendors put their prefix before the IndexedDB name in order to implement IndexedDB while it wasn't stable enough. So what you see here is that I'm using a variable called IndexedDB, and I'm checking whether Windows support IndexedDB, the object, or WebKit IndexedDB object, which is for Chrome, or Moz IndexedDB for Firefox, or MS IndexedDB for Internet Explorer. Another thing to notice here is the IDB transaction. In the past, transactions in IndexedDB were requested using the read_write or read_only properties. It was changed lately, I think 1 year ago, and now it's just read_write and read_only. So what you see here is my fallback to all browsers. Okay? I'm saving a database name called grocery store DB. I'm creating a storage name called grocery store, and let's see how it works. The first thing that I will do is I will initialize my IndexedDB. In order to initialize an IndexedDB, what you need to do is to open the database. In order to open the database, you need to request from IndexedDB, open the database for me. This is a request. I said all the API in IndexedDB are asynchronously. So I request from IndexedDB, please open, and I'm giving it a version number. In order to change my database in IndexedDB, you need to give the open function another version. Okay? So if I want to change the version of the database, then put 2, 3, 4, 5, whatever, in order to change it. Only when you give a version number which is not the current version number, an event called onUpgradedNeeded will be fired. In that event, and only in that event, you can change the IndexedDB implementation. So once onUpgradedNeeded is called, what I'm doing here is I'm creating my object store using the createObjectStore function with the store name that you saw earlier, and with the key path, which is the key in the object. Key path says to IndexedDB, this is the key that you will use as the index for the object that are stored. That means that the key that I'm giving in the client side is going to be the key of the object. Another thing to notice here is that I got a request to open the database. Okay? That request might finish in an error, and I'm wiring an on-error event, or it might succeed. Once it succeeds, the request is successful, then I have an instance of the database in the result property. Okay? And here I'm calling the callback for the initialization, meaning that I'm going to do something after I've finished creating my database. Let's go up and let's see other things. Okay, so we saw the storage save item function that I used in web storage. It was very easy, yes, set item with the data. In IndexedDB, it's not like that. The first thing to notice is that I'm creating a transaction. Okay, once I have the instance of the database in my hand, I got it here, again, in the self.db, and I stored it. So once I have that instance, I can ask the object store, please give me a transaction. Okay, so I'm giving the object store name, okay, and a transaction of what I'm going to do, whether it's read-write or read-only. Okay, please don't use read-write transactions for read purpose. Okay, it's read-write is more CPU consuming. So once I have the transaction, only from that transaction I can get an instance of the object store and work with it. Okay, so I'm grabbing the object store that from the transaction, and in order to save the item, I use the API of object store called put, and it will put the item inside of my object store. Once the transaction is completed, a callback for the onComplete event would be called, and here I'm just doing a callback that I'm getting from outside. Okay, from the request, I can wire the onError or onSuccess events. In the onSuccess, I'm just saying item was saved to the database using the logger, the backlog that you saw in the application. Remove item does the same thing, like you saw earlier, meaning that I'm creating a transaction against my object store, grabbing the object store instance, and using the delete function, which gets a key and delete the item from the storage. Get all items, it's much more bigger. I'm creating a transaction, again, the first two lines of code. I'm creating an in-memory array, and I'm opening a cursor against the storage. You have cursors in IndexedDB. You can iterate all the data in an object store. So I'm opening a cursor that won't open a cursor, that just requesting to open the cursor, and I'm getting the request. Once the request is successful, I can get from the event argument the target.result, which is my cursor. If I'm getting the cursor, then I'm taking the cursor.value as the item to push in the items array, and I'm saying to the cursor, please continue, using the continue function. Then I'm still iterating, and the onSuccess would be called again. So this is cursors. In order to get items, you have the get by key function that you saw earlier with web storage. Again, I'm creating a transaction, I'm grabbing the object store, and I'm using the get by key. Get will give me the item stored by the key that I provided. In the event arguments here, under event.target.result, I will get the item for the get function. So I'm calling the callback with the item that I try to grab. That's it. That's all the implementation. But I need to show you a little bit of how the application changed, because everything is asynchronously in IndexedDB. You saw me all the time using the callback function. So let's see the implementation of that. Okay, first thing here is the data service. The change here is that it has a new function called init. The function will initialize the storage using the init function, which will open the IndexedDB database. Every other function here is just getting a callback function from the UI implementation. Okay, so this is the only change, the init in the data service. In the grocery store IDB, you can see that I'm sending callback functions. For example, save item local will send a callback function that will use the application cache is online and save the item remote, meaning that if I succeeded to save the item locally, then please save the item remotely. Another place here that got a change is, just a moment, save item remote, no, is here, get by key. Okay, I'm trying to grab from the database the item by its key, and I'm having a callback function that will do the same thing, like check whether I'm online, delete the item locally or remotely. Okay, so the changes are minor to the application, but the gain is very big. I have a full-blown database. I can use a full-blown index database, which is very, very good for fast retrieval of data and fast insertion of data. So this is IndexedDB, and this is our application in its final mode. And let's talk about support. As I said, not everything is supported by the browsers. So one tip from me to you is caniuse. Caniuse.com is a website that you can use to check whether something in HTML5 is implemented in the browsers. For example, you can see that web storage is implemented from I8 and forward. And in the right side of the screen, you can see web browsers of mobile phones. Okay, so you can see that web storage except Opera is supported by all of the mobile browsers from early versions. So if you have a website that uses storage in the client side, you can gain a lot, because you know mobile phones is something like 40 to 50% of internet use in this year, and probably it will rise. Most of us use our mobile phones or tablets instead of desktops. So you can gain a lot from using the web storage. More than that, you can see that offline web applications also supported in mobile. Okay? And it was mainly addressing mobile implementation. Of course, IE is behind everybody else. IE 8 and 9 doesn't support offline web application, but 10 and 11 do support it. And if I'm talking about IndexedDB, sorry, we have a lot of red rectangles here. Most of the mobile phones still do not support IndexedDB. But if you are creating websites which aren't targeting mobile phones, or web applications that aren't targeting mobile phones, you can see that most of the modern browsers do support IndexedDB, and you can use it in your applications. With that, what we saw here, let's wrap up a little bit. We saw here three options, three APIs in HTML5 that enables you to store data in the client side, or to take your application offline. These APIs are web storage, IndexedDB, and offline web application. I didn't show you file API and file system API, which are two other storage options that you can use. What you gain from file API and file system API is the ability to get a sandboxed file system from the browser and to read and write files to that file system. You can even read folders there, okay? That doesn't mean that you get to play with the user's file system. That means that you get a very strict area from that file system in order to save files or to write files. To write files or to read files from there. And with that, any questions? It was very informative that you are not asking questions, or you don't have any question. Yes? Yeah, I said, it depends on the browser. The question was, is there any limit on the size of the data that you save? Don't save the pictures and video, okay? Save the just JavaScript data. I said that most of the storage options gives you between 5 to 10 megabytes, okay? And that's not a lot, but in JavaScript, that is a lot, because you don't have to have big objects in JavaScript. Yes?
Can you search IndexedDB based on the content rather than just keys and cursor?
I didn't show you the option to use indexes in IndexedDB. It has option to create indexes on fields in your objects, and then to use the index function in order to retrieve objects using that index. Okay, I didn't show you the ability to create constraints on indexes. This is another ability in IndexedDB, and this is something that you would have to read about when you are trying to write an application using IndexedDB. But these options are included inside of IndexedDB. Any other question? Yes. Sorry.
Is there much difference in performance between accessing stuff locally and when you're offline and online?
Okay, so that's a good question. Once you go the storages option in the client side, it is faster than going to the server and retrieving data and parsing it and rendering it. Okay? From the consumer point of view, it's better experience. More than that, if you are using, for example, Windows 8 and you are creating Windows Store apps using WinJS and the HTML5 and JavaScript, you use IndexedDB or web storage as two options to save data locally. Okay, so these are the main options for you as a web developer to create and store data in the client side. Hopefully, there will be more options in the future, but who knows? Yes?
Would it be reasonable to say that your save locally each time, and then say asynchronously in the background and push it to
So
while on the next one?
this is a good question. The question was when to save the data to the server. Whatever you like to save the data. You can do it in the background. I showed yesterday web workers, for example. You can do it using Ajax. When you can create your synchronization mechanisms. Okay, what I showed you is very simple, but there are libraries like Breeze, for example, that helps you to create more data-driven applications using their API, okay, and etc. So this is something that you will have to implement, okay, not you don't get it, but there are libraries that implement those stuff. Example, Breeze, breeze.js. Any other question? Okay, so let's wrap up. In this session, what you saw here is 3 main APIs that enables you to store data in the client side and to take your application offline. Since mobile phones are very, very common and people use them a lot to surf the internet, then you will gain a lot when you are using those storage options. And you will gain a lot when you take the application offline and enables users to see a website or web application once they are not connected to the internet. Don't do that today, do that yesterday. Use those storage options, use those offline abilities, because once you use them, you gain a lot more to your user experience than once you don't use them. Here are some resources. One thing is the session and the demos, which are in the first link. The API specification for web storage, IndexedDB, and offline web applications. If you want to go to my website and my blog, it's gilfink.net, and you can follow me on Twitter, writing a lot. Lately, less because I'm wrapping my book, but I'll return writing in my blog in a few weeks. And with that, I want to thank you for coming to this session, and again, use those storage options today. Thank you. Are here, and you can use them today, and you could use them in the last 2, 3, or 4 years. Okay, you are not using them probably, or you are using them, but you don't know that you're using them because libraries wrap those storages for you. But in the end, you can create better user experience by using those storages. You don't have to go all the time to the server. You don't have to render data in the server. You can create your data on the client and save it on the client side. So a recap. What is HTML5, which is related to those storages that I'm going to show you? HTML5 is just a word, a buzzword that says I have an HTML, CSS, and JavaScript for building modern web applications. If in 1997 there was the recommendation called HTML4, then HTML5 just add to that recommendation a lot of good stuff. For example, yesterday I showed the attendees of the session that you can track users using your browser using an API called Gil Location. So HTML5 is here. It is kicking and bouncing for the last, I think, 7 years. Okay, from 2006, when the first working draft were created, until now. But only in 2009 it gained a lot of attention. You know why? The people that attended yesterday's session needs to say yes. Okay. Steve Jobs told everybody to the press that Flash won't be a part of iOS ever. Browser storages. This is the main topic of this session. So, I'm Gil Fink. I'm a senior consultant and architect working for a group called Sela Group. I'm an MVP of Microsoft MVP in ASP.NET area for the last 5 years. I wrote a book, Pro Single-Page Application Development. You can buy it in Amazon or through Apress, the publisher. I also wrote, I think, 4 MOOCs, Microsoft official courses, that you can take in any Microsoft official learning center. So I have the HTML5 programming course and all the Windows 8 with HTML5 and JavaScript courses from Microsoft. I am the co-author of those courses. What we are going to do here is first recap. Who attended yesterday's session? Okay, so if you attended my yesterday's session, you probably know what I'm going to talk about in the recap, but I will do it very fast in order to get to the main thing. The main thing, we are going to build an app. That app is going to show you the transition from one situation, which is I don't store anything on the client side, to storage on the client side, and we are going to take that application to offline, meaning that we are going to create an offline web application that uses storages on the client side when you're connected, and when you're disconnected also, okay? At the end of the session, I'm going to give you a lot of time to question and answers, and I will summarize the session in order to make you understand that storages in the client side, okay? So how can I create an interactive website or web application using only HTML, CSS, and JavaScript? That question just drove HTML5 to what it is today. And most of the modern browsers give you a lot of the power that HTML5 brings. Not IE, okay, but most of the other browsers. Sorry, Microsoft. And you can use a lot of the things that I'm going to show you today with all of the browsers, except IE8 and lower, of course. So if you are targeting IE6, 7, and 8, please don't do that. Okay? So what's in the umbrella of HTML5? First, we have a lot of new semantic. We have a lot of new elements, structural elements, inline elements that you can use today in most of the modern browsers. More than that, today's session we are going to talk about offline and storage. We're going to talk about 3 APIs in HTML5 that gives you the opportunity to store data on the client side using client-side storages, and to take your application to the offline. Make it an offline web application. No more 404 pages when there is no connectivity in the user's computer. Device access. I said the geolocation. I can use GPS and the vibration of mobile phone, or even the accelerometer using JavaScript. Yes, plain JavaScript. I can access a webcam, I can access a microphone using get user media function, and etc. A lot of... Good morning, everybody. How are you? It's the last day of the conference with sessions, and tomorrow there is a workshop day, so I'm starting the first session in the last day, and what a great hall. So big. I want to start with a scenario. In a web page, you want to create a drop-down list. Okay, drop-down list needs some data, and you have options to get that data from the server and do stuff. So one option is to render all the data for the drop-down list on the server. You know, traditional web applications, I do create the web page with the drop-down built in with all the options, etc., etc. The other option is, of course, to get the data with Ajax to the client side and do with it, create with it the drop-down list. But what if I could bring that data and use storages on the client side? You know, once you bring that data to the client side and you have more than one drop-down list and you have a lot of Ajax requests, or for example, a lot of rendering on the server side, you just pay with CPU on the server, or you pay with latency or web resources that you go to the server, bring data, and etc. And this is what I'm going to talk about in this session. I'm going to hopefully show you things that you never saw, or you saw but you don't use right now. I'm going to show you how to use storages in web pages on the client side. Devices are enabled using just JavaScript. More than that, connectivity. Who tried to do a cross-domain request using JavaScript? Raise your hand, please. You know what happens when you try to do that. The browser will stop you or block you because you can't do that using JavaScript. So you need to do JSON-P or other things to try to do it on your own. No more. Cross-origin resource sharing is a new API that enables you to do cross-domain requests using JavaScript. More than that, yesterday I showed WebSockets, a new bidirectional socket communication using JavaScript on the client side and WebSocket server. You can create semi-real-time web applications using WebSocket API. It will never be real-time because it's not C++ or C or other language, and you have the network to pass. Okay, but it's semi-real-time. Multimedia. HTML5 brought us the video and audio tags that enables you to hear audio using a new element called audio and see and hear video using the video tag. 3D and graphics. The 3D and graphics, you have two main models that you can use to create graphics in the browser. You have the canvas element that helps you to create using JavaScript pixel graphics, 2D pixel graphics, or you can use WebGL API to do 3D graphics in the browser. And you have SVG, Scalable Vector Graphics, which is another model that enables you to create elements of, for example, ellipses, rectangles, triangles, etc.